Gato paper was published in Archive on 12 May 2022. It's another great work from DeepMind. In this video, I'm going to explain this paper in detail. Let's see what is Gato. Gato is a scalable generalist agent that uses a single transformer or a neural network with exactly the same weights for multiple tasks. These tasks can be playing Atari, capturing images, chatting, following text instructions, navigating in a simulated 3D environment, or controlling a robot arm, and many more. It was trained on 604 various tasks, and each task has its own set of modalities, observations, and action specifications. The idea behind this work was inspired by the great language models such as GPT-3 that adapt by context to multiple tasks. Here, the same train network or same set of weights are applied for multiple tasks. Let's see the benefits of using a single neural network. The first benefit of using a single neural network is the diversity of training data. It can use multimodal training data. Then it decreases the necessity for handcrafting policy models. And all we know, generic models have proven to outperform than domain-specific approaches. Now I will talk about the methodology of Gato. During the training phase of Gato, data from various tasks and modalities are serialized into a flat sequence of tokens passed and processed by a transformer neural network, which is comparable to a large language model such as GPT-3. In the training phase, the loss is masked, and that's why Gato only predicts action and text targets. Gato takes multimodal data as input such as images, text, joint torques, button presses, and other discrete and continuous observations and actions. These multimodal data are serialized into a flat sequence of tokens known as tokenization before feeding into the network. Then these tokens are serialized before training. We can divide the procedure into 4 steps. The first step is tokenization of multimodal data. Second step is sequencing the tokens or data. Step 3 is embedding input tokens and setting output targets. And step 4, training. Now let's see the steps in detail. In step 1, tokenization of multimodal data. As you know, Gato takes multimodal data and it uses different strategies of different modality, such as sentence piece is used to encode text, whereas images are first processed into raster order sequence. For the discrete value, it uses raw major order integer sequences. Continuous values are flattened into sequence of floating point values in a raw major order. In step 2, sequencing data. Gato uses different strategies for sequencing tokens or data for different modality of input. For an example, text tokens in the same order as the raw input text. Images pass tokens in raster order. Tensors in raw major order. Nested structures in lexicographical order by key. Agent episodes as time steps in time order. Agent time steps as observation tokens. In step 3, the input tokens are embedded. Gato uses 2 types of embedding. Tokens belongs to image patches are embedded into vector per patch, whereas tokens belonging to text, discrete, or continuous valued observations or actions are embedded in learned vector embedding patch. Gato has 2 key modules. The first one is parameterized embedding function that transforms tokens to token embeddings, and the next one is sequence model that outputs a distribution over the next discrete token. Given a sequence of tokens and parameters, they model the data using the chain rule of probability. And the L is the loss function. Here, M is the masking function. Gato paper provides three versions of networks, depends on the hyperparameters. You can see the hyperparameters of the three versions of the networks of Gato paper. Let's talk about the key literature of Gato paper. Gato uses LLM-like architecture. LLM-like architecture are also used in decision transformers and trajectory transformer. Gato is largely inspired by the works such as GPT-3, Gopher, and Flamingo. All are language models. The key findings of this research are twofold. The first one is transformer sequence models work well as multitask, multi-embodiment policies. The second one is they also show potential in few-shot out of distribution task learning. Thank you for watching this video. If you get interested in my video, please subscribe my channel. Thank you so much.